Here, so now we will see another analysis on applied Python. So this is going to be a case study that we will try to use Python to fetch and manipulate the data and understand data. Then we will be get familiar with the some common Python libraries, no the or we can say the function that we use for EDA, that is Enforcement Data Analytics. So what about the context of the data set that we are going to use? So basically we have a case study of Stack Overflow community that this is of 2018, and we are checking here the responses of over many developers. They took the 30-minute survey in this year. So about the content, this is the 2018 developer survey result that are organized on Kaggle in two tables. First one is survey result public and another is survey results schema. So survey result public contain the mean survey result, one respondent per row and one column per question, and survey result schema contains each column name from the main results along with the question text corresponding to the column. So there are around 98,000 responses in the public data release, right? And these responses that are what we consider is qualified for analytics purpose based on completion and time spent on the survey and include at least one known PI questions, right? So let's get start with importing the necessary library that we need, the matplotlib for plotting the graph, then numpy and pandas, and the pyplot for the plotting graph again. Now we are reading the CSV, that is n survey result public CSV, which is in our machine. So I'll provide these data set, that is survey result public and survey result schema. Okay, once we have read the data set, now if we check the DF shape, that is survey result public CSV. So here you can see we have, this is the row and columns, and this is our data set looks like, where we have many columns: respondent, hobby, open source, country, whether they are student, whether they are employee, formal education, and under grade major, right, company size there if they are working, and their developer types, whether they are full stack engineer, developer, manager, and all, so on so forth, all the parameter that is required by Stack Overflow while we registered. So if we read this description, so we can see that we got an error above stating that there is mix of data type in certain column, right? What it is talking about, mix of data type means here you can see, let's say in this student, yes, whether it is a student, no, it could be yes, but it is part-time. So if it is not student, so clearly no, but if it is a student, so it is saying partially answer, that is no or yes, and something like this, exercise 3 to 4 times per week, or no, I don't typically exercise. So there are many such ambiguity, or we can say different parameter that we are getting. Now from the data above, we can see that the column company size has number and string. Again, if we check the column company size, so here you can see it is containing numbers as well as string. Okay, similarly it is the case for certain other columns that we got, and the warning message says either specify the data type of each and every column or set low memory, that is false. So the latter is most feasible for this data set having 129 columns. So what we'll do is, first we are getting the data, that is our DF public CSV, and we are saying that just low memory equals to false. That means we do not get the same warning again, right, whether they are different data types or not. So most warning are often harmless, but it is necessary to be cognizant of the same. So the way to deal with these warnings is often documented in the library that we use. So now let's check out a few questions. So if we check the head of our questions data set, so we have columns and question text, right? And we can see how the table is structured. Yeah, and each column in data frame is essentially a question, and the column name is an alias for the questions, right? So these are the alias for the questions. We can see any questions in its entirely by fetching it from the question data frame. So let's say if I want this fourth question, that is student, I want to get the question text. So question dot log, I'm passing the 4 right at the fourth index, and get the question text. I only need the question text, so it will return this text: are you currently enrolled in formal degree granting college or university program? So we use this log to fetch specific value from the data frame, right? Hope you remember we also have ilog, that is basically work in tabular format. Like if we want to pass any particular cell, that is ith row and ith column, so we can do that. But here we are accessing it by texting, right? So but if we did not know the position of certain column name whose question we want to fetch, right? So in that case we can also set our own index, that we can assume that okay, now I pass this index and this could be the value, right? And the index would be our column in place is true, so all the index that are 1 2 3 are replaced by the column. So now we can access our row on the basis of these column name, right? So now that the index has actual name, right, and we can use log function again. So here you can see this time we are not passing any index or number, we are just passing the index value because the index got converted, right? So again we got the same value. We are also explore many columns name or df mean by fetching their respective question from question data frame, right? One of the first few things we do to understand the data is look like info, right? So how the info look like? So if we pass the df.info function, it will return all the information, like these are the entries I have, 0 to 98,854, column are 129, right? And data type is float, int and object, right? So it is giving only unique values. So of the 129 columns, 41 are float type, first one is integer type, and the rest 87 are object type. So this is the telling. We have 98,855 rows in total, and the amount of memory this data set is occupying is the RAM of 97.3 MB. So this is the info looks like. Now if we check the NA value, so what we are doing is df dot is NA, right? So here after we will proceed with exploring and understanding the data without any obvious comment like we did earlier. So here you can see that number of missing value, it will return that whether it is NA or not. So where to apply in pd dot value counts. So how much NA values are there, so this you can see that it is returning. So number of missing value in each of the column has been written, and treating missing value is beyond the scope of this notebook, means we will ignore it for now. So this is not necessary as of now. So in respondent you can see that we have non-null values. So these are non-null values is printed, and if there are any null, so it will return okay, there is none value for all column. So if we convert this in np.array, right? So here you can see that we are converting numpy array df columns. So each column name are here now, you can see that. So all these got converted into one array. And if we check the df country dot value counts dot head, so in df country there is one column, right? And we are checking the value count, and we just need head of them. So value count in each country will be like this, but if since we call head here, so it will return top 5 values. So in value count, if we go for US, so these are the countries value. India, this is the country value that inside that column. For convenience, we have only displayed the top 5 countries, right? And to get a broader picture, we can create a bar plot. The plotting also visualize the data, how accurate it is, how we can see that visually, right? So let's plot a bar plot. So df.country value counts, it will count the value. I just want to plot the bar plot for only had 25 values, that is 25 countries we can say. And the plot kind is bar, okay, edge color is black, right? And light blue, that is our color of the bar, and fixed size is 15 by 5. If we go for X label, it is country, Y label is number of user, and top 20 countries is our title. So if we go for plt dot show, here you can see that we have 25 countries and it is returning all the values in that graph for all those 25 countries. Now the above are top 25 country in terms of user base. Okay, in the above plot we can add another detail and make a sketch bar chart. Alright, so to get the sketch bar chart, again we will define that. Okay, this time in the df.log, check in country. Okay, if it is in country dot value counts, again for head 25 and from there to end. Okay, and then it will check that pd dot cross tab, that we want cross tab for each bar, and top 25 country dot 20.25 open source, right? And plot a bar for this where count is bar, edge color is same that we have defined earlier, but this time it will be on open source and country. Okay, so here you can see that X label is for the country, Y label is for number, and the top 25 country in terms of user base segregated by their contribution to open source projects. These are the 25 countries. If it is open source, so it is slightly green, right, light green color here. If it is not open source, so light blue color here. So this is for all the country that we defined. Now the green bars indicate the population that contribute to open source project, and the blue indicates the rest. So if we want to the bars to be sorted the same way as the earlier plot, we can index the cross tab in that order, right? So you can see that here it was in random way, but if we sort them, okay, in highest value first and lowest value last, so we can also use that. So by doing that we will get the value counts for 25 row, okay, and it will count and return them in a sequence. So proportionally Indian users seem to be contributing more for open source project the most to other countries. In case of Turkey, the these are almost same. We check for India, so open source yes or no are almost equal, and if we go for Turkey, so here you can see that again these are almost same. In case of Iran, the open source contributor are more compared to the ones that do not contribute. So where the Iran is, so here you can see in Iran it is more compared to the ones that do not contribute. All right, let's explore the various job titles that a user holds. So if we go for df.dev type unique, so there are the job titles that we have: full stack developer, database administrator, DevOps specialist, all right, system administrator, so on and so forth. So a lot of entry have a composite job title. We have to write some additional steps to separate the titles, right? So to do that, what we'll do is we will say that df.dep type apply lambda that will map for each value. Again, lambda is nothing but an anonymous function. Okay, so here you will see that we are getting an error while we are splitting them, right? So what it is saying that float object has no attribute split. So the reason for the above error is the presence of none values in the data, right? So if it is none, so how will it split them? okay, and we can avoid it by using try except block. So here you can see that we will also get to know that how try catch works. So define that split title try, return the title dot split separator. So if it is through any error, so it will get returned here. Now we are calling that in title dev of dev type lambda, and just call this function split x in title dot head. Here you can see that full stack developer is there. It got aligned with each employee type, right? So what we are getting in the above code is series of list, okay, and the next step would be to combine these lists. So what we'll do is again title list, we have defined a list, and we are saying that we are telling that for composite title in df.dev type, just extend this, split the title with the composite title, right? So if we check the length now, np.nUnique title list, so it is giving 20. So the above list contain all the job title of the user base. There are 20 unique job title in the user pool, okay, and beyond just the job title, we can also get the count of individual job title and see the proportion of each job title in the user pool. So here now we are plotting a pie plot. You can see that in series we are defining that pd.series title list.value count is there. In explode, the np.zeros length of this series. In indexes, we are telling that in series index is in if data or business analytics and data scientist or machine learning engineer. So this is in indices. So exploit indices we have defined is 0.1. So this would be for these data science and business analytics. Now for PLT figure we are defining the figure size, and this is a pie plot type of our plot based on the series label, that is series index. Autopex we are getting value up to 1.1 decimal, right? Shadow is true, okay, so each will have their own shadow. Explode we have as defined those explode here, and text props, the font size we have given is 14. So here you can see if we go for full stack developer, it is 16.1, backend developer it is 19.3. There are marketing or sales professional, so this is 0.4%, and if we go for data scientist or machine learning specialist we have 2.6%, data or business analytics 2.7%, right? And this is the shadow that we are talking about. Now the proportion of users who are in analytics or ML field are about 5.3%. So close to 50% of the chart are web developer. You can observe the proportion other jobs. So if we go for code explanation, we got the frequency of job title from title list by converting it to series and using the pd.value, okay, pd.value counts, right? Using these frequency counts, we made a pie chart. To pop the two specific job title, we got a boolean array of series. So where the value is equal to the specific job title, we used this boolean array to index on array of 0 and replace the value in the array with a known 0 number. So let's take a subset of the data that describe only the analysts. So analyst is df.log, df dev type is in if it is data or business analyst, and data scientist or machine learning specialist. So if we get the analysis dot shape, so we have this shape, and if we group by age, so what we'll do is analyst dot age value counts and plot bar h, right, horizontal, and invert y-axis. So here you can see we have majorly analysts of age range between 25 to 34 years old. Okay, so this is the highest age range. Now, a significant majority of the data science professionals are of the age group 25 to 34. So, to plot it in a heat map, we are importing Seaborn as SNS. This is our figure size. Heat map we are plotting, and PD dot crosstab. So crosstab with analyst job satisfaction and analyst age, right? Normalize them with column. CMAP is blues, right? And anot is true. So if they are satisfied, so this is the satisfied value. So if we go for 18 to 24 years old, okay, so slightly satisfied are 0.14%, slightly dissatisfied is 0.8%, right? Neither satisfied nor dissatisfied is 0.4%. Moderate satisfied is 43%. Moderate dissatisfied is 0.5%. Extremely satisfied is 24%, and extremely dissatisfied are 0.06%. So the 67% of the majority age group, that is 18 to 24, are quite satisfied with their jobs, and age group 45 to 54 and 45 to 64 seems to be dissatisfied with their data science job. If we talk about salaries, so analyst.log, if we get the salary type, currency, and converted salary, right, to drop an A. So salary dot head, we will get that this is salary yearly in US dollar, monthly in euros, right? So in euros, converted salary is also here. Okay, so these are the salary that we have. Now salary dot salary type dot value count. So yearly, monthly, and weekly salary is there. These are the salaries, and salaries, monthly salaries we are getting from salary of converted salaries. So this is this value. Now for I in this salaries dot index, okay, so it will go index by index. If salaries dot log I, that means that index salary type is yearly, okay, then what it will do is it will say that salary dot log I monthly salary equal to salary dot log I converted salary divided by 12. So it will give me the whole salary for per month, right? Monthly salary. If salary type is weekly, so we can also get the monthly salary by multiplying it with 4, because we have 4 weeks in a month. So this way, salary dot head, we will get the monthly salary here. Okay, so you can see that the monthly salary we got it. So if that is yearly, convert it in this way. If that is weekly, convert it in this way. So if we plot a disk plot, again by defining the subplot of 1 to shear x is also true. Now set fig height is 5, fig width is 20. Okay, box plot salaries monthly salary, excess is 0, and disk plot salaries monthly salary, excess is 1, and this is the plt dot show that we got here. Histogram in this case does not give much information because of the extreme skew in the distribution. So the data is highly skewed, hence we will look at the number. So salary dot monthly salaries describe apply lambda x format x, and for 2.2 decimal after points. So you can see that for describing this, count is there, mean, standard deviation, interquartile range is there, right, max is there. So 75% of the people have salary less than 19,140 USD, and the median salary for the data scientist is 750 US dollar. So if we go for salary, right, so salaries apply the lambda, and we are removing that semicolon and applying float here. Okay, so if we convert that in Indian salary, so this is the function for Indian salary. Indian salary, salary dot log get salary currency, apply lambda x Indian in x. So there will be Indian salary now. Okay, and Indian salary monthly salary will be there, and Indian salary dot salary. So in the monthly salary, this time Indian salary will be there. Now again for the same method that we done is to convert yearly salary into monthly and weekly salary into monthly. So here you can see that this is the sample 5 we have, or top head. So salary type monthly in Indian rupees, so this got converted into salary just because of our this method. Now for Indian salary, we are also plotting the same box plot and dist plot here. Okay, so you can say that the box plot for Indian salary and the dist plot here. So these are nothing but the outlier we have, okay, for around 20 lakh, right? And if we describe the Indian salary, okay, for all the values, applying lambda x in this format, so count is 48, that means 48 salary we have, and this is the main value. Okay, so what it is telling that the median salary for the professional in data science or business analytics field in India is about 58k. Okay, so this is the median that we are talking about. However, the max value shows that it is 2 crore. This is the max value, not 2 crore 20 lakh, which may not be a reasonable number if it is 2 crore still. So this is just because it is known as outlier. So we will learn about outlier and how to deal with them in later models, right? So if we talk about the conclusion that we covered today, so now that we got a good idea of how to plot, manipulate and draw insight and extract relevant data from a huge data set, exactly, and we still have a lot of unexplored columns in the data set, okay, that we are talking about. Let's say outliers are there. So from here on, look at the survey schema data and explore that data that you can do, right? If you find interesting, just keep working on these data set, and I'll come with another video with some interesting analysis or study. Thank you.